Hi, I am Vinod Gupta. I am Senior Director of Engineering at Rapid Food. Today I am going to talk to you about how I deleted 78% of my Redis container and it still continues to run. I have with me Rajeev here.
Thank you, Vinod. I'm Rajeev Thakur, CTO at Rapid Food.
So today we are going to talk about our community images project. We'll start with the problem overview. We'll share some results with you. I'll give you a small demo of our community images project. And we want the community to engage with us. So we'll show you how you can contribute. And throughout the platform presentation, you can use the webinar platform to ask us any questions and we'll be happy to answer you during the presentation. So what is community images project? We have collected a bank of images. These are all open source popular images. For example, we have Postgres, MySQL, and MariaDB as SQL databases. We have NoSQL database like Mongo. We have Redis, which is a key value store. We have multiple CNCF projects like etcd, NATS, FluentD. And we have some military grade containers like Redis and Postgres, all available on community images. These containers are hardened by the Rapid Food platform, which on an average produces 80% less vulnerabilities by removing the unused software from your container images. And we'll walk you through the entire journey as we begin.
That's a very healthy list of community images. Thank you, Vinod. So what we see in this picture is similar to the Rapid Food SaaS deployment. We have an edge proxy using Envoy container. It's facing the internet. And we have a React application, which is our dashboard. And then we have business logic written in Golang. We heavily use Redis for caching purposes. We use MongoDB and we use MySQL.
So when we developed our SaaS application, we were very happy. We used Golang. That is statically compiled. We had used a multi-container build system. So we had just the Golang binary sitting in a Scratch image. And we thought we have no vulnerabilities to tackle, and we were very happy to deploy. But once we created this entire architecture, we were surprised. Our system showed 840 vulnerabilities during the scan. We had 49 critical vulnerabilities and 327 vulnerabilities. Of course, we couldn't ship with this.
So how do you ship a product that has 840 vulnerabilities? Even if I don't worry about the whole list, but we have close to 50 CVEs that has a critical. So what did you do, Vinod? Did you ship this product to production?
So actually, I deleted 78% of the Redis container. This resulted in significantly lower number of packages, files, and to our surprise, the Redis continued to run with all the functionality we required. Of course, we didn't do it manually because that would have been a very tedious process and time consuming. But before we jump into the process, let me talk you through the results. So we were able to reduce the attack surface from 102 megabytes to just 21 megabytes, which resulted in vulnerabilities removed from 110 to just 30. And we removed the OS packages from 112 to 20. The number of critical vulnerabilities went down from 7 to 4 and high went down from 40 to just 15. These were amazing results, and we wanted to automate this process so that we can replicate it again and again for all our infrastructure.
So solving this problem is hard. The first question that comes to mind is, how do you automate this process? A Redis container is released by a team every other week. It comes with more packages and whatnot. And the first thing that comes to our mind is, you deleted 78% of the container packages. What's going to have an impact? Are we going to have a breakage in functionality? So based on this one, we built a system. What it does is it profiles your application in runtime and figures out what exactly is required to run the application. Now, how do you cover the whole thing? Let's say if you're using X functionality of a container, how do you cover that one? So typically what happens is you build your container. In this case, we are just doing a Docker pull for Redis container. And then you run a stub application, which takes your application, returns a instrumented container. You deploy this container, and then you run some coverage script. Coverage script I'm going to explain after this slide. And once your coverage script is executed, you just signal us to harden the application, and we give you the hardened image. And we should be doing this one before you run your full regression test. So let's go to the coverage script. Coverage script is not a test. You don't verify the results. Coverage is just a bunch of payloads to exercise your workload, covering all its functionality, what you need in your container application. It's very easy to write. Typically, it takes like 1 hour for a small application. For a complex application like, lots of business logic and whatnot, it takes typically 1 day. All you care about just is sprinkling payload and exercise your workload. Benefit of writing coverage script is that you will never lose the functionality which you need downstream when you do your regression test and whatnot. And if you do it prior to your regression test, there is very small chances that you will have a breakage in functionality.
Thanks, Rajeev. So let me show you guys how we wrote a sample coverage script. This is the sample coverage script for Redis. We just sprinkled our coverage script with few of the popular Redis commands, which we think will cover most of the functionality we needed for our software. This, you will see, is just 20 lines of commands, and we are not testing anything. We are just executing the commands, hoping to basically cover all the different executables, dynamic link libraries, as well as Python and shell scripts. Let me give you a quick demo of our system. So this is GitHub project RapidFort community images. It's MIT licensed, free for all of you to use, and please contribute. You'll see all the images which we talked about. The images continue to add. Let me go to a popular community image. So let's say we look at Redis. We are creating hardened containers for Bitnami and Iron Bank. Bitnami is one of the popular repositories which updates their software regularly and has a very non-root containers which are more secure. So if I look in this community images for Redis, you'll see that Kubernetes coverage test is literally 38 lines. We simply created a script which I showed in the previous slide, test.redis, which goes and executes these commands using Redis CLI on the Kubernetes cluster. Then we run our Redis coverage, which is some of the binaries we wanted in our system. And finally, if we want to test the entire system, we run Redis benchmark. Let me show you these tests in action. So this is the coverage script I showed you in the slides. As you see, it's still 30 lines of code. This is the Redis coverage. We wanted to make sure few of the binaries get included in our hardened image like Redis benchmark, CLI, and Sentinel. We have created GitHub actions for all these images. These runs on an hourly basis and produce the images if there is upstream change. All these images are available on our Docker Hub pages. So you can go to our Docker Hub repository and go and look at any of these images. You'll see that these are updated frequently. Last one was updated 3 days or 10 hours ago. Any of these images, you can hit the RapidFort hardened button and it will take you to the full report. You don't need to sign up for our platform. You can view the report. Here you will see for Nginx, we went down from 96 MB to just 17 MB. The number of vulnerabilities went down from 123 to 21. And we removed significant packages. We have a complete SBOM of the product. You can download the SBOM report here. We are working on supporting other common platforms features like a Cyclone DX format for our SBOM. If you click on any of these vulnerabilities, you can see how these vulnerabilities are reported from different advisories. You can look at the packages, location, and if there is a fix available, you can also look at the fix. What this makes is a conversation very easy between the security team and the engineering team. You can go with the actionable report to your engineering team to make the changes which are required. We also have RRS score. This RRS score is built on our AI platform, which predicts what's the probability of a POC available for these vulnerabilities in the next 3 months. POC means proof of concept. Once you have a POC exploit available, then you need to definitely patch this vulnerability. Otherwise, it's very easy for an attacker to just take the POC and attack your infrastructure. Let me walk you through the other parts of the system. You can look at all the files In the original container, Nginx had 5,893 files. During our test, we just used 96 files. We have an intelligent system which can understand all the different DAGs and figure out what are the files required to keep the system coherent. So we included 153 files. You can look at all the used files here, included files. You can look at all the packages. So original image had 111 packages, but in the hardened Nginx image, we are just packaging 12 packages, and we don't need any of the Golang packages. This results in removing some of the critical packages which can be exploited by an attacker if they can exec into your system, like add user. Let's look at the system calls. The original OS came with 334 system calls. The hardened system, or during the functionality, we just required 95 system calls. Hence, we removed all the other system calls, and you can download the seccom profile to ensure no system call which is blocked by us can be executed by an attacker who gets into your infrastructure. So how you can contribute to our platform? You use the standard GitHub process, you fork a repo, we have a template folder, you can copy the template, add your coverage script. If you want to test the system, you can add the standardized test. Like in our case, we use Redis benchmark, and then you simply create a pull request. So what's next, Rajeev?
So Vinod, we saw a huge list of community images that we are continuously hardening. Every moment a Bitnami releases a new container image, we basically release the hardened image. These are the next images that we are going to pick and harden. But if you have some interest, please log into our GitHub issues, and we are going to take care of that.
Thanks, Rajeev. So you can create bug or feature request or submit an image request. We recently had an image request from one of our users for RabbitMQ, and we are happy to add that. We are very active community, and we want people to request images which they want us to harden for all the open source. You can scan the QR code on the screen to go to our GitHub page.
Thank you, Vinod, and thank you for listening to our webinar.
Thanks, everyone, and please use the Q&A on the webinar platform to reach out to us. Till next time, bye from Rapid4 team.